Kumar, we can start the recording.
Yes, sir. मैंने कर दी शुरू.
Yes, thank you. Thank you. All right, gentlemen. So we were talking about rate of turn indicator yesterday. We understood what is the device, what it does. Few basic features also we talked about. कि कम से कम 30 डिग्री पोर्ट स्टारबोर्ड में ग्रेजुएशन होने चाहिए, इंडिकेशन होना चाहिए. Clear cut indication whether the ship is turning starboard or port, तो red and green का combination normally होता है. If it can be analog type, it can be digital type. If it is analog, तो उसमें numbers लिखे होंगे dial में, तो वो उसका तरीका भी लिखने का है. As suggested, 0 होगा, 10, 20, 30 will be in little bolder letters. 5, 15, 25 will be in little small, and it will be graduated for 1 degree, 1 degree, 1 degree, like that. So these are some raw facts about or requirements about the device. But we were also talking about what is the use of the rate of turn indicator. So that we have seen that during the straight course, we can monitor our progress or monitor our voyage by means of plotting position, and in between plotting position we maintain the course looking at the gyro compass or magnetic compass, whatever. So looking at the compass we are maintaining the course, but during the turn, especially in the confined waters, looking at the compass does not serve my purpose, because every second it is changing. I don't know what to monitor. अब इतना होगा, अब इतना, अब इतना, अब इतना चेंज होता रहे. So since I cannot watch it instantly, I watch it for what is the rate. इतने से इतने देर में कितना turn होगा. So that unit of time that we take is generally 1 minute. So we see per minute change. Right now इतना, 1 minute में कितना change, 2 minute में कितना change, 3 में कितना. So that is bringing in the use of rate of turn indicator. Yes, rate of turn तो होगा, लेकिन चाहिए कितना मुझको? How much rate of turn do I require to execute turn? Anyone? How much is the rate of turn that I need?
Velocity divided by the radius.
Speed divided by radius.
Yes, speed and radius. Depends on two factors. Write down this. ROT is equal to V by R. Write down. Note करो कहीं कोने में. ओके, कर लिया. अगर स्पीड ज्यादा है तो ROT क्या होना चाहिए?
ज्यादा.
ज्यादा.
अगर स्पीड कम है तो ROT क्या होने चाहिए?
कम.
कम होना चाहिए. मतलब ROT requirement is directly proportional to speed of the vessel.
V.
Very good. Opposite to that is radius. मान लो V constant कर दिया, V not changing. Radius बढ़ा तो क्या होगा?
कम होगा.
कम. क्यों होगा? क्योंकि रेडियस बड़ा है तो वो डिस्टेंस ज्यादा हो जाएगी. आर्क वाली डिस्टेंस ज्यादा हो जाएगी, रेडियस बड़ा होगा तो सर्किल बड़ा हो जाएगा. डिस्टेंस बड़ा होगा तो ज्यादा टाइम लगेगा, है ना?
जी सर.
ज्यादा टाइम लगेगा मतलब रेट कम चाहिए, वही अमाउंट ऑफ डिग्रीज बट ज्यादा टाइम में करना है तो धीरे धीरे करना होगा. अगर रेडियस छोटी होगी, डिस्टेंस कम होगा तो जल्दी जल्दी टर्न करना पड़ेगा. So it is inversely proportional. Requirement of ROT is inversely proportional to radius. This we have already derived yesterday. V by R कैसे आता है? Any questions on that? How the derivation of the speed, ROT was done?
Yes sir.
Is it clear or do you have any questions?
क्लियर है सर, एकदम क्लियर है, क्लियर है।
क्या हुआ, नहीं सुनाई पड़ा?
क्लियर है सर, क्लियर है।
क्लियर है सर।
क्लियर है, ओके, गुड गुड। For deciding the radius, how much of radius of turn, which book are you going to refer, which publication?
सर कोई पब्लिकेशन नहीं है, वो डिपेंड करता है कुछ फैक्टर्स जो आपने लिखवाए थे, LOA, ड्राफ्ट, टाइप, ये सब।
The water, stream.
Very good. It is not available in any place. It is dependent on you. अगर गाड़ी मुझको घुमानी है तो गाड़ी का टर्न कहाँ मैं लिखूंगा? मैनुअल में तो आएगा नहीं। अरे रास्ता देखूंगा, जगह देखूंगा, भीड़ भाड़ देखूंगा, अपनी गाड़ी देखूंगा, उसके बाद ही टर्न करूंगा। किसी मैनुअल में नहीं होगा। वो डिपेंड करता है कि मेरी कैपेबिलिटी क्या है। साइकिल है तो मैं ऐसे घुमा लेता हूँ, बस होगी तो ऐसे करके घूमेगी, इतनी जगह कम से कम चाहिए। तो उन सब कंस्ट्रेंट के बेसिस पे आई मेक माई टर्न। So radius has to be decided on the basis of factors that affect the turning of the vessel, which is size, type, proximity to hazard, sea room availability, the shallow water effect, the draft, trim, list, etc., etc. Good.
Very good, sir.
Right. Now, next comes the planning of the turn. There are three stages, mainly three stages of a passage or a voyage. Four we can say: appraisal, then planning, then execution, while execution monitoring. तो अप्रेजल हमने कर लिया, तभी अब प्लान करने बैठे हैं. सो वी नीड टू प्लान द टर्न, we need to plan the turn first. Once we have planned, planning will be happening some 10, 15, 20 days ago. जाना है वहां, पहुंचेंगे अभी 15 दिन बाद, but planning तो अभी करनी है. So we must be able to plan the turn depending on the constraints that we have. Chart में देखेंगे कहां से किधर से जाना है. Remember that IMO recommends that the courses have to be laid down as a straight line or as an arc of a circle, क्योंकि जहाज कभी ठक से ऐसा नहीं मुड़ती. When you give rudder, she will start slowly turning and then she will make the turn. So we need to plan it first. Then second, there will be execution, how we are actually going to turn there. Then there will be monitoring. When we are turning, we have to monitor whether we are in the right place, doing the turn as per plan or not. So these three stages will be taught. But before that, let us get familiar with certain facts about turning or handling of the vessel. Number one, something called advance or reaction distance, something called wheel over line, and something called wheel over point. One moment. Disturbing. So there will be three terms that we are going to talk about. One is reaction distance, sometimes also referred to as advance. आपने शिप हैंडलिंग पढ़ी होगी तो उसमें स्टॉपिंग डिस्टेंस में एडवांस भी देखा होगा, बट ये एडवांस उससे अलग. We will see. Wheel over line and wheel over point. Now, what is this reaction distance? The ship is a floating object in the water. She is moving at a given speed. She is loaded or light or whatever condition. She has got a momentum. Momentum is equal to mass into velocity. Massive ship, whatever velocity, there is lot of momentum. What does the momentum do to a body? It provides inertia. What is inertia? That a body will be in the same condition unless and until a force is applied to. जो चीज रखी रहती है वहीं पड़ा रहता है. Body at rest will remain at rest. जब तक कि आप पैर से ठोकर ना मारे, धक्का ना दें, वो वहीं का वहीं रखा रहता है. Then there is linear momentum. Something in motion will continue to remain in that motion. आप गाड़ी चलाते हैं, सब कुछ करके न्यूट्रल करके छोड़ देते हैं, फिर भी गाड़ी चलती रहती है. थोड़ी देर के बाद रुकती है क्योंकि फ्रिक्शन वगैरह से, एयर फ्रिक्शन, टायर का फ्रिक्शन, उसके चलते फोर्स लग रहा है, ऑपोजिट फोर्स लग रहा है, इसलिए रुक रही. अगर नहीं होता तो चलती ही जाती. तो मोमेंटम ऑफ द शिप makes it continue in the same direction. Now when I apply the rudder, I am trying to turn the vessel, but the vessel tendency is to keep on going on the straight line. So there is a distance traveled by the ship on the same course before she starts turning. हमने rudder दे दिया, लेकिन वो immediately turn नहीं करती. The ship will continue on the same course straight. जाते जाते जब रडर का इफेक्ट लेना शुरू करेगा तो आगे जाकर के फिर टर्न करना शुरू करेगा. That distance which the vessel travels on the same course before turning, यहाँ रडर दिया, the ship continues like this straight. रडर दिया हुआ लेकिन फिर भी स्ट्रेट चल रही. अब यहाँ जाके धीरे धीरे टर्न करना शुरू करेगा. That is called reaction distance, denoted by F. Letter F, capital F. I don't know where it is coming from, but it is just denoted by F.
तो शिप हैंडलिंग में इसको एडवांस ही तो कहेंगे.
मैंने कहा तो कि reaction distance or advance. But okay, we go on the board for this. All right, so in ship handling there is something called stopping ability. Stopping ability of the ship, अगर आप यहाँ पे हैं, full ahead जा रहे हैं, आपने stop किया यहाँ पे given पे stop किया engine को and full stern दे दिया, तो जहाज जो है वो चलती जाती है और यहाँ जाकर के एक लिमिट के बाद आगे जाना बंद हो जाती है. तो यहाँ पे जहाज स्टॉप हो गया और यहाँ से आगे फॉरवर्ड नहीं जा रहा. तो one is this, which is also known as advanced.
Head reach, sir.
This is related to stopping ability. This advance is related to stopping ability of the ship. But what we are saying, if the ship is going on a course, आपने यहाँ पे रडर दिया, ये यहाँ के बाद चल रही है, ये फॉरवर्ड चल रही है, ये हमने तो स्टॉप करके फुल स्टर्न दे दिया था. अच्छा, यहाँ पे हमने रडर दे दिया जहाज में, बट शी कंटिन्यूज ऑन द सेम कोर्स. यहाँ तक सीधा चलती जाएगी, मोमेंटम के चलते द रडर इज नॉट टेकिंग इफेक्ट, बट आगे जाकर के अब टर्न करना शुरू करती है, यहाँ पे टर्न शुरू करती है. सो दिस डिस्टेंस इज एडवांस और ऑल्सो reaction distance. Takes so much of time or distance before reacting to the rudder. So this is number one term that you should be familiar with. Another term is कि अगर ये हो रहा है ऐसा, और हमने लेट में रडर दिया, यहां नहीं देकर के आगे में दिया रडर, तो जहाज यहां से घूमेगी। अगर पहले दे दिया तो यहीं से घूम जाएगी। बट आई नीड टू गो ऑन अ प्लान ट्रैक, मुझको चाहिए जहाज की इस पे चले। सो वेयर डू आई गिव द रडर, इस इनिशियल कोर्स पे मैं रडर कहां पे दूं जहाज में? सो फॉर दैट देयर इज अनदर टर्म, something called wheel over point. If this is the initial course, if this is the final course, this is the plan that you have. We will do the planning right now. If this is the plan, then at the place where we have to give the rudder is called wheel over point. But ये point होगा कहां? कैसे पता चलेगा कहां पे रडर देना है? So for that we have something called wheel over line. Now what is wheel over line? Wheel over line is a line parallel to the final course. इसके parallel एक line होगी. So this line should be parallel to the final course, और उसके बीच का distance जो दिया जाता है, what is the distance between the two is given by t, denoted by t, is equal to f sin theta plus r into 1 minus cos theta. Now what is f here? What is f? Yes, gentlemen. F is the reaction distance. What is theta? क्या हो गया जी, सब सो गए?
एंगल जितना
Angle
घूमना है
at the
सर,
center.
जितना घूमना है।
Angle of alteration. R is what? The radius of turn. So we will take a look at this. How it is coming, उसको हम बाद में करेंगे. But this is part of the planning. When you are doing the plan, the complete recommendation now will be that the courses have to be drawn as a straight line or as an arc of a circle with wheel over point mark. ये पॉइंट मार्क करने के साथ तब आपका प्लान कंप्लीट होता है. There should be clear cut indication where the wheel has to be given. प्लानिंग आपने करी, एग्जीक्यूट करते समय चीफ ऑफिसर होंगे या कैप्टन होंगे, he should know where to give the rudder. So we will take a look at this a while later, but we should now be familiar with the reaction distance F and the wheel over line, which is this line, and wheel over point. So one line definition for this reaction distance, it is the distance traveled by the ship on the initial course before she actually begins to turn. Also sometimes referred to as advance, is denoted by capital letter F, and this value may be obtained from maneuvering booklet. Maneuvering booklet is the ship handling parameters of the ship, जब ट्रायल होती है शिप की, ट्रायल रन पे उसके बिहेवियर को नोट करते हैं, व्हाट इज द स्टॉपिंग डिस्टेंस, व्हाट इज टर्निंग एबिलिटी, टर्निंग सर्किल एटसेट्रा एटसेट्रा, तो उसमें बड़े सारे इंफॉर्मेशन को नोट किया जाता है, उसी में ये रिएक्शन डिस्टेंस भी होगा. बट इफ इट इज नॉट देयर, इफ यू डोंट वांट टू सी, then this distance can be taken, the distance, reaction distance can be taken for medium ships as 0.1 mile. Large ships 0.15 mile. Very large ship 0.2 miles. F की value may be taken safely as this. एक मीडियम साइज का जहाज 100-120 टन 10 meters will be beginning to turn in one cable distance. A larger ship, 150 meters or so, will turn 1.5 cable, it will go straight and then begin to turn. Very large ships, 200-250 meters, etc. or more, will go 2 cables before she begins to turn. Why the difference? Because the size makes different kind of momentum for the same speed of the ship. अगर तीनों शिप 12 नॉट से चल रही है फॉर एग्जाम्पल, तो इसका मोमेंटम अलग होगा क्योंकि छोटी जहाज है, इसका ज्यादा होगा, बड़ी जहाज है, इसका सबसे ज्यादा होगा मोमेंटम, और उस मोमेंटम को तोड़ने के लिए वी रिक्वायर मोर टाइम, सो द डिस्टेंस ट्रेवल्ड इज मोर. So do we understand what is reaction distance? Do we understand what is reaction distance?
Yes, sir.
Yes, sir.
Good. Do we understand what is wheel over line?
Yes, sir.
Please specify, try putting it in words, define it.
Sir, it is line parallel to the course we are going. We have to go and point
No.
पे होता है.
Line parallel to the final course, ऐसे
Yeah, the
बोले.
final course. हाँ वही मतलब. We have to
हाँ, जो
final
going,
course.
तो अभी तो going हम ये कर रहे हैं.
Okay,
Going is this, but this is to go. This is
go.
a line parallel to the final course. आगे बोलिए.
It coincides with the point on the ये wheel over point से coincide करती है on the course we are doing right now.
Very good, but you forgot about this. इसका distance तो बताना पड़ेगा ना कि parallel है तो कहाँ है, कितने दूर है.
हाँ sir.
तो एक बार फिर कोशिश कीजिए, redefine, फिर से try कीजिए.
It is the line parallel to the final course with a distance t is equal to f sin theta plus r 1 minus cos theta.
Yes. And where this wheel over line intersects the final course, sorry, initial course, that point is called
Wheel over line.
wheel over point.
Wheel over line.
Somebody else, yes, कुछ बोल रहे थे?
Wheel over line.
हाँ, वो तो हो गया. Now somebody else define what is reaction distance.
The distance moved by the vessel when it takes time, when it completely stops, or सर ऑल्टर करने के पहले जितना डिस्टेंस वो आगे बढ़ जाता है वो.
ओके, फिर से बोलेंगे. अभी आपने स्टॉपिंग की बात करी, ये वाला एडवांस
ब्रेक द मोमेंटम ऐसे ही बोल सकते हैं सर.
ना ना ब्रेक द मोमेंटम वगैरह वो सब कंफ्यूजिंग हो जाएगा.
The distance covered after the wheel is given and it starts to turn.
Yes, something like that. The advance or reaction distance is the distance traveled by the ship on the initial course from the point where the wheel is given to the point where she begins to turn is called reaction distance. ठीक है? Right. So now that we are familiar with this, we will find out how this formula comes. That we will be doing later. But now the planning of the turn. We are supposed to be planning a turn. We have got the chart and we have to turn. Remember that the courses will be as a straight line or as an arc of a circle. अगर सर्किल है तो उसका सेंटर भी होगा और रेडियस भी होगी. तो there can be two conditions in which we need to plan the turn. चार्ट में या तो दो ऐसा कंडीशन होगा जहां पे एक आइलैंड है और इस आइलैंड के खास डिस्टेंस रखते हुए we have to make the turn. So the planning may be required around a radar conspicuous object. पहला केस हो सकता है कि आइलैंड वगैरह जैसे चीज रडार पे दिखती है, हमें चार्ट में होगा, तो मुझको उस आइलैंड से एक खास डिस्टेंस मेंटेन करके टर्न करना है. आई नीड टू कीप अ फिक्स्ड डिस्टेंस फ्रॉम दैट island or a buoy or a submerged, not submerged, or some other kind of material object which is visible on the radar. So we may have to plan the turn around a radar conspicuous object, or there can be a situation where we don't have anything to see. So in that case, it will have to be around an imaginary point. Maybe it is now this imaginary point is not visible on the radar. क्यों? क्योंकि यहाँ पे शैलो पैच है, 2.5 मीटर का डेप्थ है. यहाँ पे चार्ट में आपको दिख रहा है कि यहाँ पे कुछ नहीं, मतलब डेप्थ कम है, तो आपको इसको दूर से निकलना है. बट दिस इज नॉट विजिबल इन द radar. So what we are saying that when you are planning the turn, आपको जब कंडीशन मिली कि भाई प्लान करो, we have to go to certain from this port to that port, रास्ते में आपको एक जगह टर्न दिख रहा है, थोड़ा confined waters है, उस केस में you are looking for two conditions. Do you have something on the radar that you can see, or you don't have anything on the radar? Do we understand that the two conditions in which we need to plan the turn? Remember कि मैं चार्ट में अभी कोर्सेज वगैरह डालूंगा और उसमें टर्न बनाऊंगा ये वाला. So the two conditions are understood when you need to plan the turn.
Yes, sir.
Okay. So first case first, around a radar conspicuous object. Planning the turn around a radar conspicuous object. सबसे पहले क्या करेंगे? तो वी आइडेंटिफाई द ऑब्जेक्ट जिसके अराउंड टर्न करना है. देन We decide the radius of the turn. We have to decide the radius of the turn. R कितना होगा? कैसे decide करेंगे? Again, considering all those factors and in consultation with master. So we have decided the radius. Second point. Third point, keeping the radar object as center, we draw an arc of radius r that we have already decided. Now, along with this, passing tangentially to this, you draw your initial course and the final course. So, simple as that, when you have a radar conspicuous object, you first identify this, number one, then you decide it, number two, then you draw an arc of radius r, number three, then passing tangential to this, आपने जो कोर्स करना है, जो कोर्स पे जाना है, आप कंपास पे आएंगे, उसको मेजर करेंगे, यहाँ पे आके एक लाइन खींचेंगे, यहाँ पे आएंगे, एक लाइन खींचेंगे. So 4 and 5. क्या क्या किया आपने? What is the first step?
Identify the object.
Next,
Add the radius.
number 3,
Keep the radius as center. Draw the radius r.
arc. Arc of radius r.
Radius r.
Then next,
Find passing tangent to the circle. Draw final and initial course.
initial and final course. पहले final और initial में नहीं. पहले initial तब ना final. ठीक है. So this is simple method of doing it. Next one is planning the turn around an imaginary point. I don't have anything to see. I don't know where to keep the center. दिख नहीं रहा. तो इस केस में प्रोसेस थोड़ा उल्टा है. But before we go to that process, how to plan, let us get a concept clear. Supposing you had this plan. इसमें रेडियस ये था, ओ यहाँ पे मान लीजिए कि है आपके पास. This is theta, so this also is theta, right?
Yes, sir.
Okay. This is right angle, this is right angle. Because it is tangent.
Yes, sir.
So now let us say if this is A, B and C. AB is the initial course, BC is the final course. From here, can we find out the value of AB and BC? This is of course R.
हाँ sir.
तो AB और BC की वैल्यू पता लग सकती है क्या?
हाँ जी sir.
Very good. Will you try or should I continue and explain how to find out?
कर सकते हैं try sir, but time waste होगा class का.
Okay. ठीक है. So for the benefit of the class, what we do, we join these two lines. From B and O, we join these two. So now we have two triangles, BCO, ABO. In this, the two of the sides are same, are they not?
Yes, sir.
One line is common in between them, the hypotenuse. This is right angle triangle, so angles are also same. That means this and this are congruent. The triangle ABO and BCO are congruent.
Yes, sir.
That means in this AB is equal to BC. That can be established कि दोनों बराबर होंगे.
Yes, sir.
दो साइड्स बराबर है तो तीसरा साइड बराबर होगा ही होगा. Now in this, if these two are congruent and total angle was theta, so this angle must be theta by 2 and this also must be theta by 2.
Yes, sir.
तो एंगल हमारे पास हो गया थीटा बाई 2 इन राइट एंगल ट्रायंगल. बेस है हमारे पास आर, तो ए
P
बी
by R.
निकल जाएगा या नहीं? निकाल के
Sin
बताओ
theta
क्या
equal
होगा.
to AP by R.
तो क्या होगा? ए बी इज इक्वल टू,
Sin theta by 2R.
क्या बात कर रहे हैं, 2r कहां से आ गया?
Sin theta by 2 into R.
Hey, we are comparing the base and perpendicular. So tan theta by 2, this angle
Tan theta by 2 is equal to AB by R.
is equal to P by H, sorry, P by B. Is that right?
Equal to, yes, sir. AB by R.
P is AB, AB, and base is what? R. ठीक है? सही है या नहीं?
Is equal to R tan theta by 2.
That means AB is equal to, सही कहा आपने, R tan theta by 2. So this distance is R tan theta by 2. This one also is R tan theta by 2. Is it okay?
Yes, sir.
So now that we know that this part of the turn in this AB and BC are equal, which is given by R tan theta by 2. R बड़ा होगा तो ये भी बड़ा, थीटा जो होगी उसके हिसाब से होगा. So now having known this concept, now we plan the turn. इसमें होता क्या है? In this, the first part is decide the radius. पहला पार्ट जो है, first step is decide the radius. How will you decide the radius?
A वाले formula sir. AB is equal to R tan theta by 2.
Decide the radius considering all those factors.
Decide
in
the factors.
calculation
The factors
master.
लेके factors
हाँ
लेके.
सर factors है सर.
हाँ, वो डिसाइड कर लिया, वो करेगा तब ना R tan थीटा मिलेगा तुम्हें.
हाँ जी सर.
हाँ, तो R तो वहां से आना है. All right. Then second step is draw the initial and final course. मतलब इसमें हम पहले ही शुरुआत करते हैं इनिशियल एंड फाइनल कोर्स से. जो चाहिए, जहां से निकलना उसको ड्रॉ कर दिया. अभी हमारे पास वो आर्क नहीं है, टर्निंग ट्रैक नहीं है. स्ट्रेट कोर्स तो हो गया, बट वी वांट अ टर्निंग ट्रैक. अब यहाँ पे रख के डालते हैं तो ऐसे बनता है, इधर कहीं और रखते हैं तो ऐसे बनता है. तो वी नीड टू फाइंड आउट द सेंटर हेयर, कि मैं कहां से इसको ड्रॉ कैसे करूं.
दोनों टेंजेंट होनी चाहिए.
यस, टैंजेंट होना चाहिए. मतलब ये जो सेंटर होगा एकदम सेंटर में ऐसा आना चाहिए कि दोनों से टैंजेंशियली पास करे. मान लीजिए कि दिस कोर्स वाज ए बी This course was BC. So third point is that on AB and BC, cut us a segment is equal to R tan theta by 2. तो डिसाइड कर चुके हैं आप रेडियस, तो इसके ऊपर में और इसके ऊपर में एक सेगमेंट कट कीजिए. इसका ये डिस्टेंस कितना हमने रखा?
R tan
R
theta by
tan
2.
theta by 2.
R tan theta by 2. अब यहां से नेक्स्ट we draw an arc like this of radius r. ऐसा इधर कट करेंगे और यहां से भी ऐसे कट करेंगे. From point, let us say this was P and this was Q. So from P and Q, cut an arc inside the turn. Now the point of intersection is your center. Then turn the compass and draw the arc like this. So you have the initial course, you have the final course, and you have the turning track. Understood?
Yes, sir.
So there are two methods of planning. One method is turning around or planning the turn around a radar object. Second method is turning around an imaginary point जिसमें center नहीं था, लेकिन हमने center निकाला. कैसे निकाला? R tan theta by 2 करके निकाला. So now I want you to open your notes. जो हमने आपको नोट्स भेजी है, या तो क्वेश्चन आंसर वाली ही कर लीजिए, उसी से देख लेते हैं. In that, read about the planning of turn around a radar object and around an imaginary point. Open that file, read the steps, familiarize yourself with the answer as to how will you plan the turn around an imaginary point. How will you plan the turn around an radar object? Please go ahead and do it. Let me sit down. Yes, are you doing it?
Yes, sir.
Okay, Sparsh, read a question which talks about this from the rate of turn indicator questions. There will be more than one part of the question. First part will be planning the turn. दूसरा हो सकता है execution, और जो हमने बात नहीं किया, तो don't get worried. We'll talk about that. But I want you to familiarize yourself with the steps of planning. दोनों केस में radar, imaginary point. Sparsh Gupta.
Sir, yeah, how will you plan your turn around an imaginary point? Describe the method of constant radial turn for executing this turn. How will you
वो
monitor that?
execution में आएगा. Second part is execution, जो हमने बात नहीं किया, सिर्फ पहले point पे बात करेंगे. Okay, Akhil, Stop. Sparsh, you were speaking. Read the answer.
सर वो कंप्यूटर स्टक हो गया हुआ
क्या हो गया?
सर कंप्यूटर हैंग कर गया 1 मिनट में करता हूँ
हाँ ठीक है, ओके। Okay, somebody else read. Okay, Akhil, you go ahead. Read the answer. Question and then answer.
Question number 2. How will you plan your turn around an imaginary point? Describe the method of constant radial turn for execution this one. How will you
We are
monitor
not
it?
talking about the second part. Only how will you plan the turn around an imaginary point? Please go ahead. Read this part of the answer.
Answer. Planning the turn around an imaginary point. Point number 1. Describe on the radius R. Decide the
Describe
radius.
and decide.
Decide the radius of turn, considering factors such as type of ship, LOA, breadth list, trim, displacement, shallow water effect if applicable, sea room availability, navigational hazard, effectiveness of radar, external factors, etc. Point number 2. Draw the initial AB and the final course BC. The alteration being theta degrees. फिर point 3 है on AB and BC cut a distance or a segment of r tan theta by 2 such as PB is equal to PQ is equal to r tan theta by 2.
Are you understanding what we are talking about?
हाँ सर वो सेगमेंट बनाना है r theta by 2 डिस्टेंस का. फिर उसके
Good.
बाद पॉइंट 4 था कि फ्रॉम पॉइंट्स P and Q cut an arc of radius r such as the intersect at point O. So इसका मतलब है कि r tan theta वाले से r tan theta by 2 जहाँ पे कट करेगा उससे आर्क मारेंगे सेंटर पे r रेडियस का दोनों तरफ से. फिर जहाँ पे वो मिलेगा लास्ट पॉइंट keep O as center, draw an arc of radius r such as the arc touches AB and BC tangentially at point P and Q.
ठीक है?
हाँ जी सर.
So that is what planning of the turn around an imaginary point. Another question will be there where you have to plan the turn around a radar object. Question number 3, 4 देखो.
है सर.
Okay, read. अच्छा, you stop. You stop. Om Prakash. Mr. Om Prakash.
Yes, sir.
Identify the question where you have to plan the turn around radar object.
Yes, sir.
Question number? ओम प्रकाश, इतना देर क्यों हो रहा है? Yes, go ahead. Om Prakash, don't keep the class waiting here.
Yes, sir. Yes, sir.
सर
पहले
आपकी
इतना
आवाज
टाइम
कट रही है सर, समझ नहीं आ रहा।
क्या नहीं आ रहा समझ में?
सर आपकी
क्या
आवाज
समझ में नहीं आ रहा?
डिसऑर्ट हो रही है सर, कट कट के आ रही है।
कट कट के आ रही है। तो जो इतना जो क्लास में बताया कुछ समझ में नहीं आया आपके?
नहीं सर, पहले तो ठीक था, अभी कट कर।
और जब क्वेश्चन पूछता हूँ तब खराब हो जाती है ना। सचिन, विनोद कुमार मीना,
Yes, sir.
have you identified the question where you have to plan the turn around radar object?
Yes, sir. Question number 3, sir. With the help
Yes,
of
please
net
read.
space extent planning.
थोड़ा जोर से माइक्रोफोन नजदीक लाके।
Yes, sir. Question number 3. Explain planning and turning with constant ROT, sir. Planning that answer, sir. Planning the turn around a conspicuous object. Number 1. Identify the radar object on chart around which to plan the turn. Second, decide on the radius R of the turn considering factors such as type of shape, LOA, tray, least trim displacement, shallow water, effect, sea room availability, navigation hazard, effectiveness of radar, and external forces. Keeping radar object as center O, draw an arc of radius R. Draw the initial and final course, passing tangentially to the arc at points P and Q, respectively, the alteration being theta degree.
ठीक है? So simple. So these are the two methods of planning. You have seen it on board. We have discussed. You have also seen in the question paper, or not question paper, but question answer की form में भी. So we'll be stopping here. Next class we will be doing the execution part. How to execute the turn. जब जाएंगे वहां पहुंच जाएंगे. प्लानिंग तो पहले हो रही थी. अब जब पहुंच गए, how we are going to do this execution. What are the methods of execution? That we'll be talking about in the next class. Any questions now? Okay.
सर नेक्स्ट क्लास में
Okay.
क्वेश्चन सोच लेंगे।
ठीक है. All right. Bye bye then. Time's up. We meet again in the next class. Happy weekend. Enjoy your weekend also. थोड़ा पढ़ाई भी करो, मस्ती भी करो. Bye bye.
थैंक यू
Thank you,
सर।
थैंक यू सर।
आप भी करें सर।
Yeah. Thank you.